Welcome back. In this video, we will be discussing the history and organization of the periodic table. Although the idea of grouping up similar elements had existed earlier, the first true periodic table was published by Dmitry Mendeleev in 1872. This table showed that existing elements could be organized in order by increasing mass. The elements were also grouped by similar properties. Now, the rows of elements are currently referred to as periods because they repeat periodically, hence the name of the table. The columns continue to be called groups and still contain elements with similar properties and reactivities. The primary difference between Mendeleev's original table and our modern periodic table is now elements are ordered by increasing atomic number rather than atomic mass. Atomic number is the number of protons that an element has, reflecting the total charge in the nucleus, something we've learned about in previous videos. Now, the first group of elements in the periodic table is known as group 1A. Most of these are referred to as the alkali metals. Now, all alkali metals are highly reactive solids that are only found in nature as salts, such as the sodium in the salt sodium chloride. The name alkali comes from Arabic, and it has the same root as the word alkaline, which is used to describe a solution that's basic. So why are these elements alkaline? Well, it was discovered that the ashes of burnt vegetable matter were basic when they were dissolved in water. In English, these ashes were originally called potash, and that's where we get the name of another common alkali metal, potassium. The next group, 2A, are called the alkaline earth metals. Now, these elements are also very reactive solids that, when placed in water either as pure elements or as metal oxides, create alkaline solutions. Of the alkaline earth metals, calcium is probably one of the most familiar elements, and it's known to be an important component in the compounds that make up bones of all vertebrates. Just below calcium in the periodic table is the element strontium, which we can predict, since it's in the same group, to have similar chemistry. In fact, strontium is so similar, it can replace the calcium in our bones, and this normally happens without any problems. Unfortunately, there is a form of strontium that's radioactive called strontium-90, and this can accumulate in our bodies in the bones, resulting in cancer or leukemia. Now, group 3A is right here, and this contains aluminum, probably the most common metal in the Earth's crust. Regardless of its abundance, aluminum has only become cheaply available relatively recently. Before new technologies to refine it were developed, it was actually more expensive than gold. In fact, when the Washington Monument was completed in 1884, the capstone was a single block of pure aluminum weighing a little more than 6 pounds. And this was the largest single piece of aluminum that had ever been cast in the world at its time. We can keep moving over to group 4A. Now, group 4A contains the elements carbon and silicon, as well as tin and lead. It may be hard to imagine that all of these elements share common properties, but we can see that Mendeleev's original reason for putting these elements together in a group still applies. Atoms of all of these elements will react with atoms of oxygen in a 1:2 ratio, resulting in familiar compounds like carbon dioxide, which you're currently exhaling, and silicon dioxide, which makes up glass. Next up is going to be group 5A. Group 5A is sometimes called the pnictogen group, and this name actually comes from the ancient Greek word for choking, reflecting on the first element in its group, nitrogen. Now, you would not be able to live in a room that contains only nitrogen gas, hence its name. This group also contains phosphorus, which was one of the first elements to be discovered in modern times. It is named for its observed property to glow faintly when exposed to air, the name's actually coming from the Greek legend of the light bearer. Continuing over, we have group 6A. And this group is called the chalcogens, which means born from copper in the Greek. Now, the reason for this is that many of the elements in this group are actually found in copper-containing ores. Of course, oxygen is also in this group, and it's the most well-known element of the group. It's the most abundant element in the Earth's crust, making up nearly half of our ground, ocean, and atmosphere by mass. Continuing to group 7A, we have the halogens. This name again comes from Greek, this time for the words for salt, halo, and forming, gin. So this is because, again, we see these elements are all very reactive and will form salts if exposed to metals. Table salt, for example, is sodium chloride, which I mentioned earlier is the product of sodium metal in group 1A and chlorine in group 7A, a halogen. The last group, group 8A, is called the noble gases. These elements are called noble gases because they all exist in the gas state and are noble in that they rarely react with other elements. Now, neon is a popular example seen in glowing signs. However, I would like to point out that not all of the so-called neon signs that you've seen actually contain the gas neon. Only the red and orange signs actually have neon gas in them. All of the other ones with their varying colors, from yellow and green to blue and white, actually contain argon gas. And in those cases, the color comes not from the noble gas, but instead from a coating on the glass tube. Collectively, these 8 groups are known as the main group elements. Now, you might notice I left a big space here in the middle. There are 10 groups here. And together, these 10 groups are called the transition metals. Now, groups of transition metals do share common properties. For example, we can have group 1B here, sometimes called the coinage metals, which consists of copper, silver, and gold. Now, these are excellent conductors and display outstanding ductility and malleability. However, only a few of the many transition metals are commonly used in general chemistry, such as iron. In fact, iron is the most abundant element on Earth, as the core and mantle of this planet are almost entirely iron. Now, one last thing you might have noticed, I have a couple of rows placed underneath the periodic table here that we don't talk about very often. These elements are usually called the rare earth elements. However, contrary to their name, they're not actually all that uncommon. The problem is they can be found together in big groups, and it's difficult to separate them out. So until recently, there wasn't a whole lot known about these elements. Like the transition metals, there's a wealth of chemistry that has been discovered about all of these elements, but we're only going to cover a few of them, such as uranium and plutonium, in general chemistry.